Good morning, everyone. Today, I am going to explain the topic backpropagation network in deep learning. I am Mrs. Padmashri from SNS College of Engineering, Coimbatore. Let me explain the concept of backpropagation network. As we already discussed about the neural network, the neural network has the three layers: input layer, hidden layer, and the output layer. And the same uh, deep shadow neural network, which has a limited number of hidden layers. And this is the another type of neural network called backpropagation network. It is also a multi-layer feed-forward network. Why it is called backpropagation? Because it is going to backpropagate the error. Error is backpropagated. Hence, it has got the name called backpropagation network. It uses supervised training process. It has a systematic procedure. It has an algorithm to implement the back propagation and training the network, and it is using error detection and correction methods. This is the architecture of back propagation network. Architecture that you are saying is same as that of neural network architecture. We have the input layer and one hidden layer, and the another one will be the output layer. Sorry, here we have two hidden layers. So the neural network can have more than one hidden layers, right? So here in the back propagation network, we are considering two hidden layers. So input layer which receives the input and it transmits the input to the hidden layer one. So the input, say the input is x1, x2, x3, and the weight associated with each input is considered as W11, 12, 13, 14, etc. And we have V11, V22, V3. So this is the hidden layer. And the output layer, you have the output is denoted as Y1, Y2, Y3 till Yn. So this is the architecture of a back propagation layer. Okay, what is a back propagation network? Actually, this network is valid only for differential output functions. So, training the data present in the back propagation has a three stage. One is a feed forward of input training path, calculation and back propagation of associated error, adjustment of weight. So, back propagation network mainly has three stages. The first stage is feeding the input. From the input layer, all the inputs are feed forward to the next layer. What is the next layer we have is the hidden layers. Hidden layer 1 and 2. The hidden layers are denoted as V, and input layer associated with the weights are denoted as W, and next the output. So between the hidden layer and the output layer, if there is any error exists, what we will do, we will just back propagate the error input. So after correcting all the errors, the weights will be adjusted and then the data will be transmitted to the output layer. So this what the entire architecture explained. Let me explain about the back propagation algorithm. It takes four steps: initialization of bias values, weight value, feed forward process, back propagation of error. If there is any error, back propagated, and after finding the error, the new weight and bias has to be updated. Then that values will be sent to the output layer. So this is what the step by step algorithm. Step 1 initializes the weight, the random value near 0, while stop condition, the loop has to be executed until it falls. We need to repeat the step 3 to 10. For each training pair, we have to do the steps from 4 to 9. So feed forward of inputs. Each input xi is received and forwarded to the higher layers. That is the next layer. As I said, the hidden layer. Next, back propagation of error. So the back propagation of error, which has a step 7 and 8, the back propagation is calculated. So from the step 2. From the step 2, we receive the input from the input layer, then it will pass to the hidden layer, then the weight for each and every input, the associated weight will be calculated. From the hidden layer, we'll send it to the output layer. So in between, if there is any error is there. So this was calculated in the step 3, back propagation error. So it is represented as del k, which is equal to tk minus yk f of ink, and f of ink is considered as the output value. And step 8, we have the input value, which is equal to summation of del into vg. So del value is the activation function value, and vjk is the hidden layer values. After calculating this error, updation of the weights and the bias has to be done. The weight correction is del wij, because why here we are doing the weight correction? Already the weight will be calculated for the initial inputs, right? And if there is any error, that has to be back propagated and has to be corrected. Error detection and correction. After correcting it, we need to update the weight. So this step 4 is followed for weight updation and correction. The del is weight correction, w is a weight, which is equal to alpha into del k zj. Alpha activation function, and z is the output. Same bias correction is denoted as del wj, which is equal to alpha into del k. So this step will be executed, and weight updation and also the bias updation will be continued. Then the new weight and new bias will be calculated. How to calculate the new weight? With the help of the formulas, the new weight will be and the new bias will be calculated. Then that will be transmitted to the output merits. It has smooth effect on weight correction, and computing time is less. Weight are small, very small, 100 times faster than the perceptron model. Has a systematic weight updating procedure. And learning, it has some of the, it has got some of the demerits. Selecting the hidden layer in hidden layers is an issue. Like as I said, like for shallow network, we'll be having the limited hidden layer. But for neural networks, or if you did back propagation network, the number of hidden layers will be more. So which layer has to be selected? Selection of the hidden layer will be the drawback in the back propagation network. Selection of hidden layer is an issue. The network get trapped in local minima, temporal instability, and network paralysis. Like we are going to do weight updation correction, right? So there is a changes in the weight. So therefore, the training process will not get the accurate result. Training time is more complex. Time is more. It takes more. So it is very difficult to solve a complex problem on time. These are all considered some of the drawbacks. Thank you.